Moving on. All right, so now we have some parametric work to do. Number 41, we've got x defined as 2 cosine of t, y defined as 2 sine of t. So this is probably a nice little circle. And we want to know the equation of the line tangent to the curve at the point defined by the given value of t, and our given value of t is at pi over 4. So what we need is y equals mx plus b. That's the equation of a line. We'll start out this slope. Slope is going to be change in y over change in x, or the derivative of y with respect to x. So we want dy dx. What we can get by differentiating with respect to t is dy dt and dx dt. Now if we take dy dt and divide it by dx dt, we'll invert, we'll multiply, it'll work out to this. So let's take the individual derivatives with respect to t. dy dt will be 2 sine of t, derivative of sine is cosine. Dx dt, derivative of cosine is negative sine. Alright, I'm going to plug it into this formula. So that's going to be 2 cosine of t all over negative 2 sine of t. That's going to be negative cosine of t over sine of t. Now this will equal cotangent, but I don't know any cotangent values. I'll put cotangent in here, but in terms to evaluate this for b, I'm going to leave it as it is and find out what my actual slope is here. So let's plug in for t. So this will be negative cosine of pi over 4 over sine pi over 4. Cosine of pi over 4 is radical 2 over 2, so is sine of pi over 4. That's negative radical 2 over 2 over radical 2 over 2, which would be complicated if they weren't the same. So that's our slope right there, negative 1, which is the cotangent of pi over 4, but as it cancels out, we can just use negative 1. So if y equals negative 1x plus b, and to solve for b, just need to find out what x and y are. Luckily, we have a formula for each one, and we know where we're trying to do it. So our y value is going to be 2 sine of pi over 4 equals negative, our x value, 2 cosine of pi over 4 plus b. That'll be, this is radical 2 over 2. This is radical 2 over 2. Plus b. So these two cancel. That's radical 2. These two cancel. Negative radical 2 plus b. Add radical 2 to both sides. So we have 2 radical 2 equals b. Now we just put it back together. Of y equals negative x plus 2 radical 2. (43) is much the same, except for now our x value is going to be defined as secant squared of t minus 1, and our y value is tangent of t. So it's secant and tangent. I hope those cancel at some point. That would be nice. And we're evaluating it negative 1/6. No, we're not. Negative pi over 4. Evaluating t at negative pi over 4. So let's go ahead and do the same thing we did before. All right, looking for that y equals mx plus b. We've got to find dy dx. We'll do it in terms of t. Let's go ahead and take the derivatives first this time, then plug them in. So dx dt. Now we got secant squared. So we know the derivative of secant, but we're going to change this up. So this is all this squared, right? So this is going to be 2 times the secant of t to the first times the derivative of secant of t. Derivative of secant, the secant tangent. And this minus 1, that just goes to nothing. So this was a squared up here, brought it down, 2 secant of t to the first times the derivative of secant, which was secant tangent. dy dx, or sorry, dy dt, derivative of tangent is just secant squared. So we got our slope, which is dy dx, the same as dy dt over dx dt, which when we plug it in, will be 2, we got a secant squared here, times the tangent of t, all over secant squared of t. Oh, I like how this is turning out. Those go out. That's 2 tangent of t. That's our slope. But we want the slope at t equals negative pi over 4. And the tangent at negative pi over 4 is negative 1 times 2 is negative 2. So we have y equals negative 2x plus b. Need to take this at t equals negative pi over 4 to plug that in for y and x. For this y and x, so y equals the tangent of negative pi over 4 times negative 2 times the secant squared of negative pi over 4 minus 1 plus b. Tangent of negative pi over 4, we just found that out not too long ago, that's negative 1. Secant squared of negative pi over 4 minus 1. Let's go over here on the side for a second. Alright, I know that the cosine of negative pi over 4 equals radical 2 over 2. Alright, so I'm going to move from cosine to secant squared. So that means that 1 over this, same as 1 over that, and this is secant. So this is secant negative pi over 4. If we divide by a fraction, just invert 2 divided by radical 2 is just radical 2. And so we want the squared of this. So we square this, we square that. So it looks like secant squared of negative pi over 4 just equals 2, which is convenient. So that's this much. Minus 1 is 1. So that was a lot of work for nothing. But what are you going to do? Plus b. We're happy it cancels. It could be much worse. Alright, so that's negative 2. We'll add 2 to both sides. And 1 equals b. When we rewrite y equals m, was negative 2 plus b was 1. There we go. 45. Parametric again. X definition. 45, x equals t. Bless us. Y equals radical t. And we want to know what this looks like at t equals 1/4. Now, by looking at this, we can cheat straight off if we want to. Y equals radical t and x equals t. This is the same as y equals radical x. It's the same as x to the 1/2. which if we took the derivative of it, would be 1/2 x to the negative 1/2, which if we evaluate at 1/4, that's just going to be 1/2. Let's see. Negative is going to make this 4, and square root of 4 is going to be 2. This is going to be 1 when we get all said and done with it. And we could plug it back in, but we'll leave that to the side for a minute and do it the way we're intended, taking the respective derivatives. So dx dt is going to be 1. dy dt is going to be 1/2 t to the negative 1/2. That means that dy dx equals this over that. Sorry, this over that. We're dividing by 1. It's just going to be the same. So I'm just going to leave this one part out. Just concentrate on this. So that's going to be 1/2 t to the negative 1/2, which, when we take the derivative at 1/4, that's the same as 1/2 to the 1/4, oops, to 4. The 1/2 is 1/2 the square root of 4, which is 1/2 of 2, which is 1. So it's what we expected. But here we are. So y equals mx plus b. And doing this all at t equals 1/4. So y at 1/4 is going to be 1/2. The square root of 1/4 is 1/2. Our slope was 1. X was just 1/4. Plus b. It's 1/2 equals 1/4 plus b. Looks like b is a quarter also. So y equals x plus 1/4. 47. We'll start that in the next video.